This is what we have planned for this week. We finished chapter 5, and then on Wednesday we're going to have a review. On Thursday we'll have the tests, and Friday is a holiday. Last week we have seen addition and subtraction of rational expressions. I don't want you to memorize anything. I just suggest you to have a piece of paper or a notebook, something with your formulas, all the formulas and the step-by-steps, and don't mind to write the step-by-step the way it's here. Write the step-by-step the way you can understand in your own words. For example, for addition and subtraction of rational expressions, we will need to follow this kind of step-by-step. Hello, Alani, good morning. Step number 1, you will factor out all the denominators. On this example, we don't need to factor out, they are already factored, so it's 7b and b squared. Okay. Now, step number 2, you have to find the least common denominator. And if you check this, the least common denominator on the example is 7b squared. Okay? Step number 3, write each expression using the new denominator, the least common denominator. So you're gonna multiply something here on each denominator that makes they equal to the least common denominator. But if you multiply something on the bottom, you have to multiply the same thing on the top to keep each fraction or each rational expression the same ratio. Okay? So write each expression using the new least common denominator, add the numerators or the new numerators, and write the result over the least common denominator, just like this. And step number 5, simplify if you can, if it's possible. And write down, have this on a piece of paper, write with your own words, with words that you're going to understand how to follow. The problem here is not that it's difficult. It's not difficult, but it's lots of steps, and you have to follow it the correct ones, the correct steps in the right order. So get your formula sheet, get your notebook, and write these steps so you don't forget about it. Okay? Today we will work with complex fractions, and there are 2 methods to simplify complex fractions. Method 1, method 2. Let's skip this explanation and go straight to the example, because I think you can understand applying on an example, right? So for method number 1, a complex fraction, as you have seen on the bell work, is something that have is a big, huge fraction that have on the numerator another fraction, and the denominator another fraction. So you're going to have fraction over fraction, and you have to simplify to be able to solve and to be able to have just one regular expression, not a fraction on the numerator, and another regular expression, not a fraction on the denominator. Okay, this is kind of what is complex fraction and why we need to simplify it. Method 1, let's work here. Let's say we have this expression, 5x squared over y over 10x over y squared. We're going to apply method number 1 to simplify. Procedure, add or subtract expressions in the numerator to form a single fraction. We don't need, you can skip step number 1, because you just have a single fraction on the numerator and another single fraction on the denominator. Okay? Divide the rational expression and simplify. That means method number 1 is something that we have seen before. It's a division of fractions. Do you agree? This is the same thing. We can rewrite this as 5x squared over y divided by 10x over y squared Do you all agree this is true? We can rewrite as a division, is a fraction. Then on the denominator you have a fraction, on the numerator you have a fraction, but you can rewrite as this, the numerator divided by that, the denominator. Okay? Remember this? How do we do division of fractions, of rational expressions? Do you remember? It's something we have seen a couple of weeks ago. Do you remember this? We keep, just let me give you a clue. We're going to keep the first fraction, 5x squared over y. And what should we do with this symbol here, with this division symbol? What should we do? 3 seconds, so you can answer. 3, 2, 1. Anyone remembers?
You would change it?
Yes, yes, that's right, Jacob. You're going to change into a multiplication, right?
Yes.
And then the second, the next, after the division, we have this fraction. What should we do with the fraction after the division?
You would simplify it?
No, there's one word. We?
Switch.
Yes, a switch. You flip like this. Perfect, Jacob. That's it. So the method number 1, what you're gonna do is just applying the thing that you already know, is multiplication, is a division of fractions that you're gonna change into a multiplication. You're gonna change the symbol as a multiplication. You're gonna flip the second fraction. Now you just need to simplify. If you have 5 and 10, you simplify. This is 2. If you have a y here, you can subtract. If you have x, you can subtract from the exponents. And then you will have x, y over 2. This is the answer. So very, very simple. If you, on method number 1, the method number 1, actually, you're gonna transform, we're gonna use the division rules, and we're gonna transform the fraction into a division, and we're gonna change the division into a multiplication. Yeah, you remember this, right? Keep, change, flip. That's right. That's right, Ewil. That's how you do method number 1. But I'm gonna tell you, this works well if you have a single fraction on the numerator and a single fraction on the denominator. Let me show method number 2. Any questions about method number 1? If you want, you can check the explanation here from the book. But the better explanation is this one. Is keep, change, flip. Yes? Now, method number 2, and this is going to be useful when you have lots of fractions on the numerator and or lots of fractions on the denominator, like here. See, you have 2 fractions on the numerator and 2 fractions on the denominator. If you apply keep, change, flip, you have to do lots of things. It might be complicated. So let me show method number 2 that might be a bit easier. Multiply the numerator and denominator of the complex fraction by the least common denominator of all fractions. Step number 2, apply the distributive property, simplify, and step number 3, simplify, canceling the common factors to the lowest terms if possible. Let's check how it works. And we have an example. First thing, check the denominators, and we have here 4 over 1, x, x, and x. The denominators are 1, x, and x squared, right? The lowest common denominator is going to be, find the unique factors, and one unique factor is x. We don't have any other unique factor. The only unique factor we have is x. 1 is not, you don't need to multiply by 1. It doesn't help any at all. So, and now you're going to choose the highest exponents. The least common denominator is the unique factors with the highest exponents. On this expression here, the least common denominator is x squared. So you're going to multiply the top and the bottom by the least common denominator, x squared, x squared. Apply distributive property here. So distributive property on the top, distributive property on the bottom, and you will have, let me use another color, x squared times 4 over 1, 4x squared over 1, x squared times negative 6 over x, negative 6x squared over x, and here at the bottom, x squared times 2 over x is 2x squared over x, and x squared times negative 3 over x squared, negative 3x squared over x squared. Cool? Simplify. Check everything that we can simplify. And we can simplify this x squared with x squared. We can simplify this x by subtracting from the exponent, and simplify this x by subtracting from this exponent. And that's it. See, now we don't have any denominators on top. It's going to be 4x squared minus 6x over. And on the bottom, you're going to have 2x minus 3. Very simple. And I gotta tell, it's better if you apply method number 2. As I told you, if you have more than one fractions on the numerator and more than one fractions on the denominator. If not, I think method number 1 is the best. But it didn't finish, because this I think we can simplify, still can simplify. Check, 4x squared minus 6x, we can factor out 2x. 2x times 2x minus 3 over 2x minus 3. That means we can cancel out common factors, and the final answer is 2x. Well, on the quiz, you can use method 1, you can use method 2. It's up to you. You can choose any method that you want. But I suggest, is my experience. It says method number 1 is good if you have just single fraction on the numerator, a single fraction on the denominator. And method number 2, I think, is better when you have more than one fraction on the numerator or the denominator, and then instead of just working out and making this a single fraction, it's better to just find the least common denominator and apply method number 2. And Kalia is asking, are we only finding the denominator? I'm so confused on what the answer is meant to be. Don't worry, Kalia. We are on the method number 2. We are finding the least common denominator of both and multiplying both the numerator and denominator. Let's work on our bell work today. What is going to be the answer for this bell work? Can you find the answer? You have 5 times, and then you have a complex fraction. 1 plus 1 over 3 over 2 plus 1 over 3 over 2 plus 2 over 3 plus 4 over 2, 4 plus 2 over 2. This is kind of, looks hard. Can you simplify it? Can you find a number that will represent this whole thing, this whole complex fraction? Send me your messages. And check this out. After you do all the simplifications, you're gonna know that this whole fraction here is equals to 1. 5 times 1 equals 5. And 5 is the right answer. The point here is to warm up, to get ready to work on our quiz. And now, let's move and practice. Thank you all for participating, for sending your answers. Now let's try to work on a few questions of the quiz. Let's start with letter A, and I think on letter A we can apply method number 1 because you have a single fraction on the numerator and a single fraction as the denominator. And we can transform it into a multiplication. 5x squared over 9y squared multiplied by, then you're going to flip the fraction on the denominator, flip y squared over 3. Okay? Check if you can simplify something. Yes, y squared we can simplify with y squared. And as I can see, this is the only thing that we can simplify. The answer is 5x squared over 9 times 3, 27. This was method number 1. Okay. Now let's check another example that we can use method number 2. Maybe letter F. Letter F, we can apply method number 2. The denominators that we have for all the single fractions are 2, 3, and 4, right? But 4 is 2 squared. So you write like this, 2 squared. Yes, Alani, thank you. The least common denominator is 2 squared times 3. The least common denominator equals to 12, right? Now let's apply the least common denominator and multiply the numerator by 12 and the denominator by 12. Okay? So we just found here the least common denominator, and now we are applying on the complex fraction. 12 times 2, can apply distributive property. 12 times 2 is 24 over 3 plus 12 over 2, and 12 times 1, 12 over 2 minus 12 over 4. Check if you can simplify, and definitely you're going to be able to simplify lots of things. This is 8, this is 6, this is 6, this is 3. 8 plus 6, 14. 6 plus, minus 3, 3. That is the answer after you apply method number 2. Here, this is method number 2. Right? Now, let me give you a couple of minutes so you can work by yourselves, and I will check attendance, and after that we can work together. Send me your messages and we can work on more questions.